Hey everyone, in this video we're going to learn the technique of completing the square. This will give us another way to express a quadratic expression other than standard form and factored form. In order to build into the idea of completing the square, we're going to start with some factoring. So factor x squared plus 4x plus 4. So we need a factor pair of 4 that adds to 4. So positive 2 and positive 2 come to mind. So our factors are going to be x plus 2 times x plus 2. So we can simplify this and write it as x plus 2 quantity squared. So we can write our factors as a perfect square. That means that x squared plus 4x plus 4 is a perfect square trinomial. So algebraically, a perfect square trinomial is a trinomial that can be factored into a perfect square. In that case, it was x plus 2 quantity squared. Geometrically, that means we can create a square with a side length of x plus 2, whose area is x squared plus 4x plus 4. If we go through each individual area, so the area of this square is x squared, the area of this rectangle is 2x, area of this rectangle is 2x, and the area of this square is 4. And if we add up the individual areas, we wind up with x squared plus 4x plus 4. So now we have an understanding both algebraically and geometrically of what it means to be a perfect square trinomial. What if we were going to go the other direction and create a perfect square trinomial? Well, the best way to do that would be to start with the factors. So in this case, I'm starting with the factor x plus m. Don't know what number m is. Maybe it's positive 5. Maybe it's negative 1. But we just have a general factor that's being squared. So this is going to create a perfect square trinomial. We're asked to expand this. So the first thing that we should do is rewrite this as x plus m times x plus m. Now we can distribute everything out. So x squared plus mx plus mx plus m squared. Combining our like terms, we'd have x squared plus 2mx plus m. Let's fix that. M squared. So that's an easy way to create a perfect square trinomial, is to start with the factor and square it out and get the trinomial. Well, what if they give us parts of the trinomial but not the whole thing? Maybe they give us x squared plus 2mx and they want us to come up with the constant term that would make it a perfect square trinomial. So let's look and see if we can figure out a relationship, particularly between the coefficient of x, which is 2m, and the constant term, which is m squared. Okay, so we're thinking of a way that we can use this middle coefficient of x to create the constant term. Well, what I see is I can take half of 2m, so I can divide it by 2. If I do that, I would just get m, and then if I square the result, I would wind up with m squared. So if I'm looking for the constant term to create a perfect square trinomial, I'm going to take the coefficient of x, halve it, and then square it. Okay, so let's look at using this idea with numbers. What value of k would make x squared plus 10x plus k a perfect square trinomial? Okay, so we're looking for the constant of the trinomial to create a perfect square trinomial. So we're going to take the coefficient of x, which is 10. We're going to take half of it and then square it. So half of 10 is 5, and then we're going to square it, which would give us 25. So in this case, k equals 25. If we put this in, x squared plus 10x plus 25, let's actually factor it. So factor pair of 25 that adds to 10 would be positive 5 and positive 5. So x plus 5 times x plus 5 is x plus 5 squared. That's a perfect square trinomial. Next, what value of k would make x squared minus 8x plus k a perfect square trinomial? So we're going to take the coefficient of x. So we're going to take -8. We're going to divide it by 2. And then we're going to square it. So that's going to be -4. Let's fix that parenthesis. -4 squared, which is +16. So if k is +16, we have a perfect square trinomial. So let's check it. X squared minus 8x plus 16. So we need a factor pair of 16 that adds to -8. So that's -4 and -4. So x minus 4 times x minus 4, which is x minus 4 squared. Okay, what we notice now is it doesn't matter if that coefficient is positive or negative, our technique will work either way. Other important piece to take away here is the constant will always be positive in a perfect square trinomial. Because think of the technique we use to get it. We take half of the middle term and then we square it. When we square a value, whether it's positive or negative, the result will always be positive. So what value of k would make x squared plus bx plus k a perfect square trinomial? So remember, we typically use the letter b to represent the coefficient of x, mainly in the quadratic formula and the discriminant. So we're looking to create a relationship now between that b value and the constant term. So we're going to take half of that middle coefficient, so b over 2, and then we're going to square it. So that's b squared over 4. So k equals b squared over 4. Now factoring here is going to be a little trickier. We have x squared plus bx plus b squared over 4. So we need a factor pair of x squared, of b squared over 4 rather, that adds to b. So b over 2 comes to mind because b over 2 times b over 2 would be b squared over 4. And b over 2 plus b over 2, it's like adding 1/2 to 1/2, we would get 1. So b over 2 plus b over 2, we would get b. So our factors are x plus b over 2 times x plus b over 2, which gives us x plus b over 2 squared. The reason this is helpful is if we wind up with a trinomial that's a little bit weird to factor, well, if it's a perfect square trinomial, if we created it the right way, our factors will always be x plus b over 2, that coefficient of x divided by 2. If it's negative, then it'll be x minus the middle term over 2. Okay, so that's a helpful tip to know when we're trying to create our factors. So now the question is, how would we complete the square for x squared plus 4x plus 3? So notice it's not a perfect square trinomial. We already know x squared plus 4x plus 4 is the perfect square trinomial. So how can we turn this into a perfect square trinomial? Okay, well, if we think about it, x squared plus 4, just to draw that little diagram again, right, it was x plus 2, x plus 2. So down here, this square had an area of 4. So I can break that up. Imagine having 4 small little blocks. So if I have x squared plus 4x plus 3, I really only have 3 of those blocks shaded in. So I'm missing 1. So that means if I take x squared plus 4x plus 3, I add the missing block, then I would wind up with x plus 2 squared. Okay, so that means that x squared plus 4x plus 3 is equal to x plus 2 squared minus 1. This is what a quadratic will look like after we have completed the square. Essentially, what we're saying is the expression x squared plus 4x plus 3 is equal to a perfect square in the form of x plus 2 quantity squared minus 1 little block to make them equal. Okay, so geometrically, that makes sense. How would we do that algebraically? So let's start with x squared plus 4x plus 3. Again, we know what our expression should look like we're figuring out how we can do that algebraically. So the first thing that we should do is put the first two terms in parentheses. Think to those last examples, right? X squared plus 10x plus k. When we just have the x squared term and the x term, we know how to find the constant that would create a perfect square trinomial. So we have x squared plus 4x plus that value that's going to create a perfect square trinomial, and then the plus 3 that we pushed outside of the parentheses. So we know how to find this missing value, right? We're going to take the coefficient of x divided by 2 and square it. So that would be 2 squared, which is 4. But mathematically, we can't just add 4 to an expression. That would be too easy, and things aren't the same. Right? We can't just give someone 4 without balancing it out. So how are we going to balance it out? Well, if we're adding 4 inside the parentheses to create a perfect square trinomial, outside the parentheses, we're going to subtract 4. If I drop the parentheses, as I will over here, if I drop the parentheses, x squared plus 4x plus 4 plus 3 minus 4, notice those 4's would simplify, and I would be left with the expression I started with. But now, what's the advantage of doing this? Right? Some of you at this point are probably thinking, you added 4 and you subtracted 4. Why do that at all? Well, the advantage is in the parentheses. By creating a perfect square trinomial inside the parentheses, we can factor x squared plus 4x plus 4 as x plus 2 quantity squared, right? X plus 2 times x plus 2, and then outside minus 1. Geometrically, that's exactly what we said x squared plus 4x plus 3 should be equal to. Right? It's the area of the square minus one of those little blocks. And we showed that algebraically, it is x plus 2 quantity squared minus 1. So simplify the following expressions by completing the square. Our first example is x squared plus 12x minus 8. So we get to practice the technique we just looked at. So our first step is to put a set of parentheses around the x squared and the x term. Next, I would rewrite it so we have more room inside of the parentheses. So x squared plus 12x plus some value minus 8. Okay, so we need to create a perfect square trinomial inside of the parentheses. So we're going to take half of the middle term and square it. So that's going to be 6 squared, which is 36. But remember, we can't just add 36 to an expression. That wouldn't be the same as what they gave us. So we also have to subtract 36 from that expression, but we'll do that outside the parentheses. By doing so, we can now factor the trinomial x squared plus 12x plus 36, and the factors would be x plus 6 times x plus 6, so x plus 6 quantity squared, and then minus 44. Next up, we have x squared minus 6x with no constant term. So we can still take the same approach of putting parentheses around the x squared and the x term. Now there's just no constant outside. So we have x squared minus 6x plus something. So we want to take half of the coefficient of x, so negative 6 divided by 2 squared. So negative 3 squared is 9. But if we're adding 9 to this expression, the only way it stays the same is if we subtract 9. We'll just do that outside the parentheses. So then we have x minus 3 squared, right? Factor of 9. That adds negative 6 would be negative 3 and negative 3 minus 9. And again, what we're doing here is we're saying x squared plus 12x minus 8. This expression is equivalent to, or has the same area as, this square, x plus 6 squared, minus 44 little blocks. Here, the area of x squared minus 6x, if we were thinking about it geometrically, is the same as the area of the square, x minus 3 squared, minus 9 little blocks. Right? That's what we're figuring out algebraically. Now what would happen if we try to complete the square for 2x squared minus 10x minus 1? Notice there's now a coefficient of x squared, and our technique always just had an x squared term. So we're going to start the same way. So 2x squared minus 10x minus 1. We're going to put a set of parentheses around the x squared and the x term. Now it is true, completing the square can only be done when the coefficient of x squared is equal to 1. Right? So completing the square, a needs to be equal to 1. Remember, a is the coefficient of x squared. So what should we do as our first step to make sure that that coefficient is 1? What we're going to have to do is factor out a 2. So if we factor out a 2 inside our parentheses, that leaves us with x squared minus 5x plus something minus 1. Okay, so we use our same technique. We take half of the middle term and we square it. So negative 5 over 2 squared. Well, 5 doesn't divide by 2, so let's just leave it as a fraction. And if we square it, we'd wind up with 25 over 4. Now, if we subtract 25 over 4, we're going to run into an issue. And that's because if I went to simplify, the first step would be to take the 2 and distribute it back out to every term inside the trinomial. So let's look what that would look like. If I distribute that 2 out, I'd have 2x squared minus 10x plus 25 over 2 minus 1. Now remember, I want to get just the original expression if I do that simplification. So that means that I have to subtract 25 over 2 to make sure that these two terms cancel out. So going back here, that means we have to subtract 25 over 2, not 25 over 4. So, key idea here. When we're figuring out what value balances our expression, we have to distribute out whatever coefficient that we factored from the trinomial. Okay, so now we can rewrite this as 2. Okay, so factoring this trinomial would be a little bit weird. So this is where that earlier tip comes into play. A factor pair of 25 over 4 that adds to negative 5 is going to be this negative 5 divided by 2, right? The coefficient of x divided by 2. Negative 5 over 2, negative 5 over 2 definitely multiplies to be 25 over 4, and that would add to be negative 10 over 2, which is negative 5. So x minus 5 over 2 squared. And now in order to combine these terms, we need a common denominator. So 1 could become 2 over 2. So we'd have minus 27 over 2. So a little bit harder here because not only did we have to deal with the coefficient of x squared, we had an odd coefficient of the x, which created fractions in our technique of completing the square. But as long as we treat this problem the same way, it shouldn't give us any difficulty. The hardest part might be the factoring. Okay, but that's where that tip of the factor being half of the middle term, half of that middle coefficient, is really helpful. So simplify the following expressions by completing the square. So now we have a leading coefficient. So we'll start by putting a set of parentheses around negative x squared plus 14x. We need the coefficient of x squared to be 1. So we'll factor out a negative 1. X squared minus 14x plus some value plus 9. Okay, so the value that completes the square, so that's going to be half of the coefficient of x squared. So half of negative 14 is negative 7. Squared is 49. So if we're adding 49, we have to subtract outside of the parentheses. But remember, we have to think what we would get if we distribute it out. So this negative 1 times the 49 would give us negative 49. So we're subtracting negative 49. So we can rewrite this now as -1. Factoring the trinomial is going to be x minus 7 squared. And then 9 minus -49 is 9 plus 49, which is plus 58. So there we have rewritten the expression using completing the square. Next up, 2x squared minus 4x plus 5. Okay, so we are going to put a set of parentheses around 2x squared minus 4x. So factor out that 2, so the coefficient of x squared is 1, minus 2x plus something, plus 5, and then minus something. Okay, so the value that completes the square, we're going to take half of the coefficient of x, so half of -2, and we're going to square it. So that's -1 squared, which is 1. But before we figure out what to subtract by to keep things balanced, we have to think about distributing out. So that would really be a 2. So we're going to subtract 2. So rewriting here, we have 2 times x minus 1. That doesn't look like a very good 1. X minus 1 squared. And then 5 minus 2 is plus 3. Okay, I'm going to do 2 more examples just to give us more practice. So the first one is x squared minus 9x plus 12. So again, start by putting parentheses around the x squared minus 9x. The coefficient is 1, so we don't have any factoring to do. You can think of a factoring of 1 if you want to stay consistent here. So we have x squared minus 9x plus something plus 12. So we want to think of that value, so we're going to take half of -9 and square it. So that would be 81 over 4, which means we have to subtract 81 over 4, right? Because sure, we think of multiplying by a positive 1 in front. So we have to factor this. Well, remember, fractions, it's helpful that the factor is going to be the -9 over 2 that we squared. So x minus 9 over 2 squared. Then we're going to need a common denominator, so 48 over 4. So that's going to be -33 over 4. Perfect. Okay, last example. 3x squared plus 15x minus 7. So we put a set of parentheses around the first two terms, 3x squared plus 15x. We're going to factor out the 3 so that x squared has a coefficient of 1. And then minus 7. Okay, so to figure out the value that makes a perfect square trinomial, we're going to take half of 5 and square it. So that's 25 over 4. To figure out what we have to balance the expression by, we have to think about distributing the 3. So that's going to be minus 75 over 4. So rewriting this, we'd have 3. We have another fraction to deal with, so x plus 5 over 2 squared. And then common denominator here, so 7 would be 28 over 4. So that's negative 98, negative 103 over 4. So our last two examples dealt with fractions because I find those are the harder ones for students to deal with because we haven't really factored with fractional constants. Hey, but that could come up in the technique of completing the square. So now the only way to really solidify our understanding here is to go practice and do a bunch of completing the square of all different types. X squared, 2x squared, negative x squared, and make sure that you're getting these correct before moving into the next video. Click the Amazon link down below for my algebra workbook so you can practice on your own. Give the video a like, and before you go, click that subscribe button so you can see more videos just like this. Thanks for watching.